welcome to this explainer. Okay, today we've got a genuinely fascinating challenge in front of us. How exactly do we connect simple Python scripts to incredibly powerful AI models like Google's Gemini without having to sit down and write all that complex network and AI logic from absolute scratch? Well, we're going to break down the exact straightforward building blocks you need to make this happen. We're going to take what seems like a totally intimidating technical hurdle and turn it into a super simple process of just snapping pieces together. Here's a really quick roadmap of what we're covering. First, connecting to the AI. Second, the modular coding approach. Third, Python's built-in data tools. And fourth, building dynamic AI prompts. All right, let's jump right into section 1, connecting to the AI, and specifically securing our access. So I want you to think about this for a second. How does your specific code actually prove its identity to Google? When your tiny little Python script reaches out across the vast internet to talk to Gemini, how do Google servers know it's really you making that request and not just some random unauthorized person? The answer to that is an API key. You can kind of think of an API key as this highly secure digital passport, or like a VIP backstage pass. It authenticates your code's request to communicate with an external service. It's your personal access token, directly tied to your account. And because of that, you absolutely never want to just leave it openly visible in your code where anyone could copy it and drain your resources. So how do we actually handle this key securely in a cloud environment like Google Colab? The exact UI process is super straightforward. First, you generate your unique key over in Google AI Studio. Second, you hop back into Colab and open the secret sidebar. It usually looks like a little key icon right there on the left-hand menu. Third, you add a new secret and give it a really clear name, something like Gemini_API_key. Finally, you paste your secure value in there and just hit save. By setting it up this way, your script can securely grab that VIP pass in the background without ever exposing the actual letters and numbers in your visible, shareable code. Moving right along to section 2, the modular coding approach, or as I like to call it, working smart. The absolute perfect analogy for this is building a wall with pre-made concrete blocks. Think about it. If you're building a wall for your house, you don't go out and mine the limestone, crush it, heat it, and mix the cement yourself, right? That'd be insane. You go to the hardware store, you buy pre-made, perfectly shaped concrete blocks, and you just assemble your structure. Programming, and specifically connecting to complex AI, works exactly the same way. Let's look at the brutal reality of these two methods side by side. On one hand, we have writing the connection from scratch, building all the heavy network requests, managing the data payloads, handling every single error all by yourself. It's incredibly time-consuming, highly complex, and ultimately pretty costly. But on the flip side, we have the modular approach, importing modules. This saves massive amounts of time and money. And honestly, most importantly, you're using pre-tested code that some other developer has already perfected. You're basically just grabbing their excellent concrete block and dropping it right into your project. So practically speaking, how do we get this pre-made block into our Google Colab workspace? It's a really clever workflow. First, we execute a curl command directly within a Colab cell. This acts a bit like a silent web browser, reaching out to the internet to download a pre-written script straight from a GitHub repository. We save this downloaded file locally as helper_function.py. Finally, we use a Python wildcard import to pull everything from that file into our current environment. That gives us instant access to a primary tool called print LLM response. Just like that, in literally a matter of seconds, we have a fully functional tool to talk to Gemini, and we didn't have to write a single line of the underlying communication logic. All right, section 3, Python's built-in data tools. Time to equip our tool belt. Python is incredible because it just hands you a bunch of handy tools right out of the box. Let's rapidly sequence through 3 essential built-in functions highlighted in the source. First up is the type function. If you feed it the number 17, it outputs int, confirming it's an integer. Second is the len function, short for length. If we input the text string I am learning, it outputs 13. A fun detail to remember here is that it counts absolutely everything, even the blank spaces. And finally, the round function. If you give it a messy division, like 24 divided by 7, and ask for 2 decimal places, it cleans it right up and outputs 3.43. These simple tools let us inspect and perfectly manipulate our data before the AI ever even gets its hands on it. I actually want to pause on that round function for a quick second because there's a really vital structural concept hiding inside how it's written, the delimiter concept. When you pass that second argument to the round function, the number 2 from our last example, you separate it from the math equation using a comma. Think of this comma like a seat divider on a crowded bus. It separates your primary data from your secondary instructions. It restricts the function and keeps your code perfectly organized so the inputs don't just bleed into one another. Finally, Section 4, Building Dynamic AI Prompts. Time to assemble the masterpiece. To test this whole system out, the source material gives us this delightfully quirky little dataset. Let's imagine we have a friend, and we've stored his name in a variable simply called name with the value Tommy. Now, for whatever reason, Tommy possesses a fractional number of root vegetables. So we have a second variable called potatoes with a value of 4.75. This is our raw, unformatted data just sitting there in our Python script. Now, here's where it gets really interesting. How do we fuse that raw data with plain English instructions for the AI? We do this using a super cool Python feature called an f-string. Notice those curly braces? Those are our dynamic placeholders. But look really closely at the second placeholder. We aren't just dropping the potatoes variable in there raw. We are actively calling our built-in round function right inside the text placeholder itself. We're formatting the data on the fly, exactly as they build the sentence. Let's break down the exact sequence here because it shows how beautifully these pieces just snap together. Step 1. Python reads our variables. It sees Tommy and 4.75. Step 2. It hits that curly brace, executes the round function, and instantly converts Tommy's 4.75 potatoes into a neat whole number 5. Step 3. The f-string finishes its job and generates the final clean text, write a couplet about my friend Tommy who has 5 potatoes. And finally, step 4. That modular building block we imported way earlier, the print LLM response function, takes that perfectly crafted dynamic string and fires it straight off to Gemini. And what do we get for all this incredibly clever setup? Well, we get this completely absurd visual payoff. The AI instantly returns this custom poem. Tommy stepped on the stage and bounced too small. He brought 5 potatoes. He's got them all. Now, obviously, it is a completely silly result, but it perfectly hits the nail on the head. Our custom script successfully took raw variable data, formatted it mathematically on the fly, dynamically injected it into an English prompt, and seamlessly communicated with a state-of-the-art LLM to get a customized response. Let's do a super quick recap to see how these building blocks formed a complete structure. We started with the API key, guaranteeing we had secure VIP access without leaking our credentials all over the internet. Then, we used a modular import to pull in pre-made AI communication logic, which saved us literally hours of complex coding. Next, we used Python's built-in tools, like round, to format our raw data properly. And finally, we wrapped the whole shebang up using f-strings to dynamically inject that clean data directly into our prompts. Everything just snapped together beautifully. The biggest takeaway here is that by using this modular approach, you completely bypass the absolute hardest, most tedious parts of AI integration. You don't have to be some master network engineer to talk to an LLM. You just need to know how to link smart Python building blocks together. You now have the exact blueprint to do this yourself. So, now that you have the building blocks right in your hands, what will you construct next? Thanks so much for joining me on this explainer, and keep exploring.